Can you please make me co-host? This is Vicky Kumar Sharma from Maths team. Hello everyone. Am I audible?
Yes.
Okay. So I hope all of you can see my screen. Can somebody confirm this?
Yes, sir.
Yeah. So just give me a minute. So all of you, today's session, it will be on peer deck. So as all of you have joined here, so I'll be showing you on screen here, you can see. So I want all of you to go to Google and type this thing, joinpd.com. Just Google this joinpd.com and it'll ask for a code. So type this code in order to join this session. Okay. Just Google joinpd.com and use this code. Do not give any space in them. Use this code XXZJAZ. Okay. So do not give any space in them. So as others are joining, how is the preparation for your exams going on?
It's going on fine. I have a few questions on graph theory.
Okay, fine. So I have some slides to share with you guys. So
Okay.
we can discuss it there and there. Okay.
Sure.
Yeah. So I can see like we are 35 of us today here and 16 of you have joined. So those who haven't joined, please join. Then only you'll be able to benefit from this. So today's session is more like I'm not just telling you, but you're solving with me. It will be like that. So you can take out your pen, paper, maybe or whatever, or writing device, wherein I'll be giving you a question and you'll be solving with me. So it's going to be like that. Okay.
Just one question. Uh,
Yeah.
Unfortunately, I missed the earlier session. This is the first session I'm joining, sir. So, uh,
Okay. So that's okay still. I think you have been given the recorded. I don't think so. It was recorded before, is it?
uh, I don't have the recorded details, sir. If you can share, it would be very, very helpful. I made a
Yeah, so
request.
but the thing is the session was not recorded and the other thing is the slides which were used by the instructor that is shared with you. So you can actually go through those slides. Okay? Okay. So I want all of you to go to this joinpd.com and use this code in order to participate in this session. And do solve with me whenever I give a question. So this will be like that. So I'll be giving you a question, so you'll be solving and then we will be discussing that particular question. Okay? And I myself will ask you the approach for solving that particular questions. so that even the others can benefit, like, if there is some multiple approach to solve a particular questions. Okay, so we'll do it that way. So today, I think in the previous sessions, we have already discussed the calculus part, and also week 1 to 4 content is already discussed, right? So week 1 to 4 is basically sets. Then you have sets, operations, relations, and functions, and then you have this straight line, quadratic equations, and polynomials. So this has been already discussed. So today we'll be discussing more on functions such as exponentials and logarithmic functions. Then we'll discuss some of the questions on graph theory. Okay, so we'll discuss the most important thing, which is very important from your examination point of view. So we'll just confine our discussion to that part. Okay, so that's how it's going to be for today's session. So I can still see you, most of you haven't joined yet, but I'll start the class. Those who haven't joined can still join this session. All you have to do is go to joinpd.com, just use this code, and then use this code, sorry, use this link, that is joinpd.com, and use this code in order to join this session. Okay, so I'll just start the class now. So again, as the classes is going on, you can still join the session. That's perfectly okay. So as you can see here on the top right corner, you can see that the code is written, right? XXZ ZAZ, right? So it's already given the code, and you know that how to join. It's you have to go to joinpd.com and use that code. Okay. So yes, for today's session, we are going to discuss. It's like a common for both programming and data science students. Uh, so my name is Vicky Kumar Sharma. I'm a maths course instructor here. So how to join this session? I think I already told you in the beginning. And how we are going to do this session is I'll be giving you a questions, and I'll be giving you like 3 to 5 minutes for solving each questions, and then we can discuss. So maybe I can ask you to give your approach for solving that particular question, and how did you arrive to an answer. Uh, I can ask you to raise your hand, and then you can actually raise your hand, and then you can unmute and speak. And then finally, I myself will discuss what is the approach for solving that questions. But the best way to learn from this session is to actually solve by yourself. Okay, so let's do it that way. So how do you basically see the questions on your screen in this particular application? So it's going to be here on the left side. You will see the description of the question. And here at the center, what is the question that is to be answered? So maybe if you have an four options, so maybe the four options will be visible here. And if you're using, let's say, a desktop, or like, let's say if you're using a mobile, so you can see the view, it will be shown like this. Okay. And for answer submission, I don't think so. You have to submit anything. You just have to type it there. I'll get the response. Okay. So that's how it's going to be. So next. Okay. So this is just a test problem. How is your preparation going on for exam? So you can just write something. I'll just get the response. This is just to get a practice of it. That how it goes, right? So I'm getting the responses. So we can just see the response. So you see whatever you type, I'll get to see here. It's great, good, not started. It's going fine. Need to work a lot, sir. So you can see that this is how we are going to get the response. Okay. So even if you delete, we it get to know like, yeah, what is the thing. And whoever types this, I'll have this record in the backend. So you cannot write anything unnecessary, even that is there. So of course. So this is how it's going to be for today's session. Okay. So as you can see now how we are getting the responses, right? So you just have to enter some value, enter something, and I can see it on the screen. So that's how it's going to be. And all of us can see who is writing what and what not. Okay. So even though you cannot see the identity of the other person, but I have the data in the backend wherein I can actually always see what is been written and what has been deleted and whatsoever. Okay. So that's how it is. So I hope you understood how the session goes now. So this is just to know what is the crowd here. Uh, so choose an appropriate option with respect to the exam which you are going to appear. So you will, if you are on the peer deck, if you are on the joinpd.com, you will see two options coming in, right? So you will be able to participate there. So just choose any one among them. Okay, so those who haven't joined yet, please join this session. Then only you'll be able to get benefit out of this. All you have to do is you have to just type joinpd.com on your Google and enter this code, which is shown here at the top right corner, and do not give any space in them. Okay. So let's see what are the responses. Mathematics for data science is dominating. So there is no programming, mathematics for programming. So basically elementary mathematics, nobody is here from the programming side. Or is there anybody here? If you can just unmute and speak. Whoever is writing diploma, I mean for maths paper for programming. So I assume like there's nobody. This was for both of you. Let's see, but okay, fine. That's okay if they are not here. I don't know for what reason. Maybe I don't know if the link was shared to them or not. But yeah, that's okay. Over here we can see that whoever are here who's actually going to write, the data science paper for maths, right? So we can just orient our discussion in that way. So I can say there is one guy. Okay, so maybe that will be just like that. Okay, so that's okay. So let's go and then discuss this. So we have some model question, which is like solve with us type, right? So you see this. So as I told you in the very beginning, like how we are going to approach this particular session. So here you can see the question, like consider a function f of x, which is like written as y, is equal to 15 e to the power of x by e to the power of x plus 1, right? So, and here you can see on the right hand side, what is the question that is to be answered? Which of the following option is inverse of f of x? Okay. So whenever you go and whenever it is asked to find the inverse of some particular function, you must first check whether it is one-to-one function or not, right? And then I believe that all of you know how to get the inverse of function. It's just that you replace the term x with y, and then you know how to get it, right? So it's given in the hint as well. So can all of you please start solving this particular question? Here the function is f of x is equals to 15 e to the power of x by e to the power of x plus 1. So this is the function and you have to find the inverse of this. Well, at first you have to check whether this is one-to-one function at all or not. If it is, then you will go for finding the inverse of it. If it is not, then you cannot find an inverse for a function which is not one-to-one. Okay. As I told you, I'll give you like maybe 3 minutes. You can solve this particular question and then we can discuss this. Okay.
Excuse me, where to get this question? How to access that page?
So you have to go to joinpd.com. Just Google joinpd.com and use the first link what you get. Just click on that link and use this code, which you can see here at the top right corner. That is XXZJAZ. So do not give any space in them. Then you shall be able to participate here. Okay. So the
Thank you.
slides has been shared in the email itself. Like if you would see the sessions link, what it was given in that session itself, when you would have got I mean the announcement or the email, there itself in the email, the link has been provided. It's a drive link, so you can get the slides from there. Okay, like 2 minutes, maybe 2 to 3 minutes, and try to solve this particular question. Do you need some more time to solve this? Do any of you need some more time to solve this particular question? So maybe I can assume that you don't need much more time, but I can just see only 15 of you have given response. Okay, which is not a good participation, but it would be good if you actually solve with me here. Then you will be able to learn this in a better way. That's what I assume. So, like I can just see there are 15, 16 responses. So let's see what are the responses. Okay. So most of you have given answer as A. You can see that. Then followed by B, C, and D is the least options. Well, let's see what is the right answer for this. Okay. So would anyone like to discuss this particular question? If you want to discuss, just raise your hand, maybe. Or you can just unmute yourself and speak. That's okay. Okay, so I assume like nobody is interested to discuss this particular question. Well, that's fine. So let me myself discuss this particular question. So you see this, first of all, whenever you have been asked to find out what is the inverse of particular function, first you have to do is first check whether the function is one-to-one function or not. If it is one-to-one function, then only the inverse exists. Otherwise, the inverse does not exist. Okay. So that's the first step that you have to do. So in the first step, how do you check that? So the very definition for one-to-one function is if f of x1 is equals to f of x2, then x1 is equals to x2. So if this condition is being fulfilled, then we say that the function is one-to-one function. So how do you actually solve this? So in this particular, if you would have seen the function, this one, instead of x, you write it as x1, right? And then you write it as x2, and then solve this particular question to arrive that x1 is equals to x2. So that's what it has been done here. So 15 e to the power of x1 by e to the power of x1 plus 1, and over here we are equating it to, so this is the first thing we have to do, right? If f of x1 is equals to f of x2, then we say that and then if we come to conclude, or like if we solve and get this x1 is actually equals to x2, then we say that this is one-to-one function, right? So likewise, like after giving this, like after substituting this value, what you're doing is you're doing some kind of arrangement, because this is in the denominator, right? E to the power of x1 plus 1, this is in the denominator, so you can do this cross multiplication and you can send it on the other side, right? And then what you have to do, you just simply multiply these exponential functions, right? So when you multiply these exponential functions inside, you get some like this. So e to the power of x1 plus e to the power of x2 plus e to the power of x1, like this is being, you're using distributive property, and then you are actually multiplying it here. Likewise, you will do it for e to the power of x2 times e to the power of x1 plus 1, and then when you multiply this, you get some expressions like this, right? So when you solve this, you see e to the power of x1 plus e to the power of x2. So this is same at this side as well. So you can actually cancel these two terms. And then what you will be left with, e to the power of x1 is equals to e to the power of x2. So now when can these two be equal? When x1 is actually equals to x2. So we finally came to this part, right? If this is happening, like if you say that f of x1 is actually equals to f of x2, and then when you solve and you find that if this is happening, this implies that x1 is actually equals to x2. If this is happening, if this implication is happening, then you say that this function is one-to-one function, okay? And therefore the inverse exists. So now you will find the inverse. So how do you get the inverse then, right? So as it was given in the hint, when you solve for inverse, what you do is you solve for x in terms of y, which gives basically f inverse of that particular question. So what are you doing here is, instead of x, you are replacing in terms of y, and then you actually solve for x, and that x is nothing but f inverse of x, right? So that's what you do. And therefore when you solve this particular question, so when you replace that particular question, so you see this, this expression you get, like f of that is f of x, which you are assuming that to be an y, is actually equals to 15 e to the power of x, and whatever the function is given, right? So now what are we doing here is we are just cross multiplying it here, and we are writing in terms of x. So basically when you just cross multiply and then you solve for x, and then finally you get x as equals to something, and this is actually f inverse of that particular function. Okay, so this x whatever you get is basically we say that this gives f inverse of x, and this is actually in a very crude way of doing this particular thing. Otherwise, there is actual way of doing it, but generally we do like this, like change of the variable and we get the inverse of that particular functions, right? So this is how it is done, like when you are in your examination point of view, so you can actually use this, but all you have to make sure is this is one-to-one functions, right? So you get this f inverse of x is equals to ln of x by 15 minus x. So therefore the option A is correct, and that was, if I can take you back, so this was the option, right? So most of you have given answer as option A. So well, that was right answer. Okay. Now switching on to the next question. So do any of you have doubt in this previous question?
Vicky, I had a question. See, the
Yeah.
thing is, I tried multiplying the numerator and denominator by e of x minus 1, but then it went into a maze
Okay.
to
All
prove
right.
that it's 1-to-1. Yeah.
Yeah. Okay. So then, did you get it now?
Yes, yes. It's a very interesting way to prove
Okay.
1-to-1 function. Very nice.
Yes. Yes. Okay.
Thank you.
Yeah. So do any of you have any other doubt on this particular question? If not, we can go to the next question. Okay. Okay. So let's go to the next question. So this is more like a logarithmic function. So it's not exactly logarithmic function, but it's a composition of two functions, right? So now consider the function f of x equals to log to the base 2 13 minus 36 plus 20x minus x square. Now what you have to do in this particular question is you have to find the range of this f of x. Okay, so maybe you can take another 5 minutes for solving this particular question. Okay, and then get the answer for this. So let's see how many of you can give the response. So I wish all of you give the response for this. See, we are like 50. Yeah, we are like 50 of us here. And if you get like response, even if like 50% of you are participating, it's actually good. So let's do that. So maybe I'll give you 5 minutes to solve this particular question. Is there anyone here who is going to write uh, this maths or basic maths for programming? Is there anyone who is going to write that paper? Okay, fine. post your answers in the chat window because this will disturb others. So you can actually participate here in this peer deck. You can just go to joinpd.com and use this code which is given here on the top right corner, and you shall be able to answer there.
Excuse me, sir. So sorry, I didn't get that.
Uh, okay, how to join this? Is it? Hello?
Hello, yes, sir.
So you all you have to do is just Google joinpd.com and use the first link. And once that link gets open, it'll ask for a code. So enter this code which you see here at the top right corner. That is XXZ So do not give any space in them, and you will be able to participate here. Okay?
Oh, okay, sir. And can you repeat that? Can you repeat
Ha,
that? So
So it's
sorry,
called
I'm confused.
joinpd.com. It's called
Join
joinpd.
PD.
JOINTDPD. P for parrot.
PD.
Ha,
Okay, thank you so much, sir.
you're welcome. So do any of you need more time to solve this particular question? Okay. So I assume that. So if you don't say anything, so I'll assume that yes, what I am asking, what my intention is something right. So I'll go with that way. So I'll assume that yes, you don't need more time to solve this. So what is the range for this particular? What is the range of f of x? So let's see what is the popular answer for this. Well, it's a diverse answer, so people are giving answer as uh, option A, option B is predominantly high, then C and D. Okay, so let's see what is the answer for this particular question. Okay, so would anyone like to discuss this particular question here?
Yes, I'd like to discuss my approach.
Yeah, please.
So I
What's your
gave
name?
my name is Ranjini.
Ranjani. Yes, please go ahead. Yes.
So my choice was answer was D.
Okay.
So the thing is, let me consider the minus 36 plus 20x minus x square g of x.
Yeah.
So you are we're able to see that it's a parabola which is opening downwards.
Yes.
Okay. Now I found out the vertex coordinates as 10 and 64.
Mm-hmm.
So the maximum value that g of x can take is 64.
Hmm.
So log of 64 to base 2 is 6.
Yeah. Right.
So you get the upper limit as 6.
Right.
Now the lower limit can be supposed the thing is g of x has to be greater than 0.
Right. Yeah.
But the thing is, suppose we say that g of x is suppose 2 raised to minus 1000,
Yeah.
for example, then we can get the value of f of x as minus 1000. So we can even go into the negative side,
Yeah.
but it can be a very small
Yeah.
positive value, which will result in a negative value for when we
Correct.
take the log. So that's why my answer is D.
Yeah, that's right approach. Actually, the answer is D only. So that's actually right. Even I have similar solution. So even I went with a similar approach. So thanks, Ranjani, is it?
Yeah,
Sorry.
yeah.
Okay, thank you. Thank you so much. So yes, so that is one way of doing it. That is even I have the solution like that. So what she did was like I'll tell you, I'll just repeat what she told. So what she did was like this there are two functions basically. F of x is composed of two functions, right? So which are those functions? You see, this is log of a quadratic function, right? So let us call this as the quadratic part, let us call it as q of x, and let us call no sorry the log part, let us call it as log 2x, and h of x as something what is given, that is minus 30x plus 20x minus x square. Now you see, this is what the graph you get for this particular thing, and you see the intercept for this particular. Okay, so we'll go for the intercept later on, but you see this is downward parabola. And why it is downward parabola? It's just that the leading coefficient of the highest degree polynomial is negative, right? So since this is negative, so you can see the highest degree is nothing but x square, and you see that the first leading coefficient of this is minus. So this indicates that this is a downward opening parabola, right? So you can see that if that is the case, then you can see the maximum value you can see only at the vertex, right? Then how do you get the vertex? So we have the formula for getting that vertex. So it's how do you get the vertex? So basically vertex is a point, it's a coordinate, right? So how do you get that coordinate? It's minus b by 2a, comma g of minus b by 2a. So what is g of x? Basically this g of x is a quadratic function. Okay, so you see this quadratic function, and here these variables are written, that is a, b and c, right? So this a, b, c is understandable from here, and that's how this formula is like this, right? So whatever this the coefficient, whatever the coefficient for this x term is, that is nothing but your b, and whatever the coefficient for x square is, that is nothing but your a. So once you substitute this in this formula, you get the coordinates for the vertex of this. So as Ranjini has solved that, so she got that the coordinates for this vertex was nothing but 10 comma 64, which even I got it here. So when you substitute this here, so you get this minus b by 2a is nothing but your x coordinate, and your y coordinate is nothing but 64. So now you see this 64 is the highest value that you get, right? So that's you can say the upper range, and then the upper value of that particular range. So how do you get that? So now when you put that you basically substitute this x value in your f of x, and then you get what? 2 to the power of sorry, log of 64 to the base 2, which is nothing but 6. So now you see this, when you take log of this particular function, you get some values here at this point, which is going to be 6, right? So now what about the other values, right? So now is this 6 the highest value or the lowest value? So what Ranjani has done is she has taken out the extreme values. Let's say she took it some some extreme values, let's say 1000, or let's say some other values, and then she checked for the answers. So she was getting more negative values, right? So if that indicates that it is actually tending towards minus infinity, so that's one indication. Well, you can actually see this. This is what even I have done. So you see this quadratic function is basically you can actually factorize this, and you see there are two factors for this. Okay, so when you take the factors for this, you get like two factors. So you know that what happens at log x is what? It's basically it goes to minus infinity. You say log 0 is basically not defined. It's why it's not defined, and how does the nature goes? It actually goes towards the minus infinity, right? So when you will notice that when x tends to 2, you see this, your function f of x actually goes to minus infinity. It's basically, it actually makes it 0, which indicates that that log 0 is basically not defined. But if you see the graph of this, it actually goes to the minus infinity side. Okay, so that is one assumption that you can make. So, or you can take the extreme value, what Ranjani has done. So you can take the extreme value, substitute it, and then you see what is the f of x value actually going towards, right? So you see this, in this way we actually get to know. So from here we got to know the maximum value that this function was taking is 6, and the least value that it can have is something minus infinity, right? So that is why the option D is correct here. So do any of you have doubt here? Again, like if you will not say anything, I'll just assume that you don't have doubt, and then I'll move on.
Sir, one small
Yes.
clarification, sir. When x tends to 2,
Yeah.
it's 2, 40,
Your voice is breaking actually. I'm sorry.
yeah, when is it clear, sir, now?
Now it's clear.
Yeah, when x tends to 2, means I'm just substituting the value of 2 in this equation. So
Right.
2 into 20 is 40 minus 4 is plus 36 minus 36.
It gives 0. 0, correct.
So how do you say it tends to infinity, sir? I'm not-
Right, right. I'll just tell you that. Now, just look at this part. Maybe I can just use this. What is the graph for this log function? Log x, where let's say this is some to the base 2 only. How will the graph be? It's like this, right? Or let's say if it is 10 or whatsoever. So you can just take log a, where a is actually greater than 1, log ax. A can be anything, like it can be 2, 3, 10 or whatsoever. So this is the graph you get. So this is basically log x. Let's say, for example, this is to the base 10, or let's say 2, right? So what happens is, now look at this particular question. So this is basically, how do you actually understand? So whenever you see, whenever whenever you are introduced to a new function, what you should know about the function is what is the domain of that particular function and how does the graphically that function look like. These are the two things that you should always keep it in your mind whenever you learn a new function, right? So now let's say this is our function and you know what is the domain for this particular function. Could you tell me? Now if f of x is equals to log x to the base 10. So what is the domain for this particular function?
0 to
Positive real numbers.
to infinity.
So it's 0 to infinity, right? Where 0 is not included, right? Right? Why 0 is not included?
Because it approaches to zero but is never actually zero.
That is one factor. That is one fact, right? So, but what happens at 0? At 0, it's basically goes to infinity, or basically to be told minus infinity. But how does that happens? Let's see. So that's what I wanted to explain you graphically. The graph for the log function is something like this. Okay. So what happens is, you see, basically, if this was my function at x equals to 2, what is the value of your f of x? This out and write down f of x is equals to log 2x. Yes. At x equals to 2, what is the value of your function f of x?
Log of 2 to base x.
So what is the value you get?
1.
Log of 2 to the base 2 is nothing but 1. So at 2 you get some value as 1. So that's something like this, right? Okay. What is happening at here? What is log 1? What is
0.
log 1? 0. So that is something happening here. So at 1 it is becoming 0, right? Then what happens to your other values? Let's say what is log 0.1? Okay, so let's see that. Log of 0.1 is what? So this essentially I can write it as what? 10 to the power of minus 1, because 0.1 can be written as what? 1 by 10, or I can write it as 10 to the power of minus 1, right? So you know the formula, this can be written as, sorry. Okay, so let me not give you as 0.2 because since if this was base 10, then that would have made sense. But over here, could you tell me, like, let's take it as 1 by,
We can take it as
yes.
0.5.
Yeah, we can take it as 0.5. So we can take x as equals to 0.5, which can be written as what? 1 by 2 or 2 inverse, basically, right? So when x is 0.5, which is basically over here, what is the value? Let's look at this, right? So this I can write it as 2 to the power of minus half, 2 to the power of minus 1. And we know that this is of form what? Log 2 a to the power of b, which can be written as b log 2a, right? So what happens is this power comes down, right? So this is what happens. So I hope you know the formula. So this can be written as 1 log of 2 to the base 2, which is nothing but 1. So this actually turns out to be minus 1. So you see this at 0.5, what is happening? This is actually becoming minus 1. Now no matter what value you give, now as the value of x decreases, right, as it approaches 0, you see this, the functional value of this f of x is actually getting more negative and negative, right? So what happens at 0, when it tends to 0, what happens? It actually goes to what? Minus infinity. You understand this now? So
Yes, sir.
that's why when you had this some quadratic equation and you some quadratic equation, and then you found that it was actually going to 0. But you know that log function, when it approaches 0, what happens to that functional value? It approaches what? It approaches minus infinity, right? You understood now?
Yes, yes.
Understood?
Okay, sir. Okay. Got it.
Understand, right? So because you see, just now I explained it, why it actually goes to minus infinity, because if you take any value lesser than, if you take between 0 and 1, any values is actually give you negative value, and as you approaches 0, what is happening to your functional value? It's getting more negative and negative, right? And it's actually going to minus infinity as you approaches 0. So what is happening to your main function, what we had it in the slide which I was showing you, there the value itself was getting 0. So if it was going 0, you can actually think of that, what will be the functional value of that particular thing? It will actually go to more negative side, right? So it will be minus infinity, right? So is that okay? So now you understood this. When x
Yeah.
actually goes to 2, when x actually goes to 2, what happens to your functional value? It actually goes to minus infinity, right? Likewise,
Okay.
Likewise, when x goes to 18, it actually goes to minus infinity side, right? And now you increase the value of x how much ever you want, but you will still see the value is getting more and more negatives. Basically, you cannot go beyond the 18 because this is what the domain for this particular function is. Well, that's fine. So now we understood that the range for this particular function is minus infinity to 6. But you see in your examination, you will be asked questions on this, like what is the domain and what is the range of particular function, right? So you see this whenever you study a function, you must know what is the definition of that particular function, right? So if I have to show you log function here, and if I have to tell you like whatever the function I had written it there, maybe I can just take it here. So you can just see my screen. You can see my screen, right?
Yes, sir. Yes, sir.
So now you see this, I had given this function log 2. And what was the expression? Could somebody tell me? So let me just look by myself. So it's minus 36. So what did we get from here was like basically what we got from here was I'll just take this factor, my x minus 2 and that 18 thing, right? So I'll just write it down here. So this is going to be x minus 2 and this was minus x plus 18, right? So now if you draw this quadratic function, it's essentially the same function. Now I'm just asking you what is the domain for this particular function. Okay, so it's just a change of question that I'm asking to you here. It's not the range, but I'm asking what is the domain for this particular question, because that is how you'll be asked in your questions. Like you'll be asked what is the domain of this particular function or like a composite function. So all you have to do is obey the definition of that particular function, right? For an example, if I have to solve this particular question, all I have to make sure is this has to be what? Greater than x minus 2, and minus x plus 18 has to be greater than what? It has to be greater than 0, isn't it? Because my log function is not defined for the value lesser than 0, right? Isn't it?
Yes.
All of you clear on this?
Sir, yes, sir. Please, sir.
Yeah. So all of us knows that the log function is defined only for positive values of x, right? So that means I have to make sure if I'm finding a domain, then I have to respect that function condition what is given, right? So what is the main definition of that particular question? So as per the definition, I have to make sure that this function has to be greater than this, the inner thing, because this x part has to be greater than 0, then only this log function will be defined, right? So if I have to make sure that this is happening, so what at what value of x it is actually going to be greater than 0? So all I can do here is I can just simply look at the graph for this, or you can just solve this inequality and get and see this. So over here you will see this. This is what the graph you get. So now you see this. For what value of x it is actually greater than 0? It is this
Between
region,
2
right?
and 18.
It is this region, isn't it?
Yes.
So you see this, when x is in between 2 and 18, then only this log function is defined, right? That means I cannot take x value beyond this. I can only take x values in them, right? So when earlier when I was telling you, you take a larger value of x and just check what is the value you get, was actually I'm telling you wrong. I shouldn't have told it that way because the domain itself is 2 to 18. So you have to check in this, right? So I hope you understand now. So now you see this, I cannot have x value beyond this, because the moment I give x value beyond this will become negative, right? You can try it out. You can take any value. You can take any value. Let's say you take out, let's say 20 you take. Okay. So when you take 20 and put this value in this, so what happens? This will become 18. And what about this? This will turn out to be what? When you substitute x value as 20, so what do you get? From here
You
you
get
get
0.
minus 2. No. 20. So when you substitute
Uh-huh.
20 here, you get 18 from this. And from
18.
this factor, you get
You
what?
get
Minus 2. So once
minus
you
2.
multiply this, you get what? Minus 36. So you see, this is log of minus 36 in that case, right?
Correct.
So you understand. But the log function is not defined for that. So the domain for this particular function is this. Okay. So quickly, can you tell me what is domain of 1 by x?
The whole real line except for 0.
Right. So how do you say? Because you see at 0, what is happening to this function? This will become not defined, right? At x equals to 0, this goes to infinity, and that is something not defined type condition, right? So we don't take those conditions. So this is for domain for this particular function is basically what? All are except what? 0, right? Likewise, you can find out for all other functions. you can solve, and this kind of practice you have to do actually for your examination point of view. Like what is the domain for this particular question and what is the range for that. I mean, just if you know the range, if you know the domain, all you have to do is just at all those boundary points you have to check what is the value, and that will give you the range. Okay, so that's all for this part. Now, I hope you understood and I told you like what is important from that aspect. So domain type questions you can actually expect and you should practice that particular type questions. So if you are to ask me from where you can practice this, so you have enough material in your NCERT textbooks, you can actually practice from there, or you can actually go with the contents what we have given, you can actually practice from that as well. Okay. So now let's say this is a third question given to you. Okay. And this is something on exponential, as you can see from here. So I want all of you to answer this particular question. So the question is, a half-life of an element is the time required for the half-life of a given sample of radioactive elements to change to another element. Okay. The rate of change of concentration is calculated by the formula. This formula is given, that is A of t. So this function is basically dependent on t values, right? So it is in t variable. Rest all are the constant value. That is something you can assume. So a naught times half of t by y. T by, it's not y, but it's a gamma, where this gamma is a half-life of the material. A naught is nothing but the initial concentration of radioactive element in a given sample. At is the concentration of radioactive element in the sample after a time t. Okay, so At at after time t, what is the concentration of radioactive material? That is the value that A of t gives. Okay, so now in this thing, some data is given. If the radium has a half-life of 1500 years, so this is basically a radium, and it says that the half-life is 1500 years, and the initial concentration of the radium of the sample was 100%. Okay, then calculate the percentage of radium in that sample after 300 years. So you see this in this particular function, you can understand this A naught is a constant and this gamma is also a constant, right? And this gamma is basically the half-life of a material, right? So all you have to do is, some data is given to you here. From this data, all you have to do is do something and find out what is the gamma value. And once you get the gamma value, you know what is A naught. A naught was initially 100%, right? So let it be as it is. So, and then all you have to do is, for what value of t, sorry, you have to find out AT value, that is percentage of radium left in the sample after 3000 years. So that is something you will have to find out. So t value is given. So first step should be to find out the gamma, right? And the next step is just to substitute that t value and get the value of AT. So this is very direct. So you can start solving this particular question.
Vicky, see, I've entered my answer. Are you able to see it?
Yeah, I'll be able to see that. So I'll
Okay.
just see in a while. Yeah, you just have to enter. It'll be visible for me.
Okay, okay. I just entered and I press enter.
Yeah, yeah, yeah. That's
Okay,
fine.
thank you so
I would
much.
have get the response.
Mm.
Do any of you need more time to solve this? Okay, so I'll assume that you don't need more time. So let's see what is the popular answer. So most of you are giving answer as 25. Some of you are giving answer as 100 as well. But let's see what is the approach. So do any of you want to discuss this particular question?
You want to know the approach, Vicky?
Yeah, like what will be the
Yeah.
approach for solving this?
Sure. If nobody else is answering, I can answer.
Yeah, fine. Yes, please go ahead.
Okay, so it's saying that the half-life is 1500 years, right?
Right.
So what you do is here T is given as 1500, gamma has to be calculated,
Hmm.
correct?
Hmm.
So A naught into half of 1500 upon gamma is equal to A naught upon 2,
Hmm.
correct? So
Right.
that makes it 1500 upon gamma is equal to 1 because the base is the same.
Mm-hmm.
So you get gamma equal to 1500.
Okay.
Okay. Now what happens is you want to know what is happening after 3000 years. So you basically have to substitute gamma as 1500 and T as 3000.
Hmm.
So you get A naught into 1/4
Mm-hmm.
because it's half the whole square.
Right.
So you get 25%.
Yeah. That's the same way even I have done. So it's exactly it's like very straightforward. So if you thanks Ranjani.
Yeah, well,
Uh, yeah. So again, so as she told, like all we have to do is like in the first step we had to find out gamma value, right? So it was given that A of 3000 was some value, right? So it was giving you as it was given that t value is given as 3000 and gamma value is something given to you as half-life it's been told, right? So half-life is nothing but 1500, right? So all you have to do is just substitute that value here. So it's going to be 3000 upon 1500, which is nothing but 2. You can see here 2 which is written, it's nothing but t is nothing but 3000 and gamma is given as 1500. So 3000 divided by 1500 is nothing but 2. So when you substitute this, you get some value as and it is you get some value. So you and see at the initial time at t equals to 0, it says that radium is 100%, right? So now all you have to do is whatever this value you get, right? So now you can just substitute this value for whatever year they are asking, right? What is the percentage? So after 3000 years, so they're asking what is the value for this, right? So after 3000 years, you just have to substitute here and get the answer. Okay. So do any of you have doubt in this? Okay. Fine. So let's go with the next concepts on graph theory. So, I hope you have gone through the content. So you would see that in graph theory itself, like in the first week uh, of the graph theory, it will be more like what is vertex coloring, then what is maximum independent set, then you will have something called vertex cover, right? Like these kind of concept, isn't it? So those are something you really have to focus on. And so I'll discuss one of the concept here, and they also I'll discuss some BFS, DFS, but let's see that how that we can go about doing that. But for time being, I'll just tell you like what is vertex coloring of a graph. Even if you don't know, I'll tell you how it is done that, and then you can practice here. So how is this vertex coloring of a graph is done? Okay, so what do you mean by really vertex coloring? So what you do here is you find the minimum number of colors required to color all the vertices of the given graph such that no two adjacent vertices have the same color. So all you have to make sure is that no two adjacent vertices have the same color. That's all. Okay. And the main objective of this problem is to minimize the number of colors. So that means you can take any color, let's say red, blue, green, whatever, but you have to make sure that you're choosing the minimum number of colors and you are covering the entire vertices, right? And what is the only one condition which is given, that if two vertices shares an edge, they will not have the same color, right? So if that is the case, then look at this. So what will I do is I'll just take one color. Let's say I'm choosing red color, okay? And then I'll start filling the vertices. So now what? If I give red color to vertices A, so as per the condition, I cannot give same red color to C. It's just that because they share an edge with them, right? Likewise, I cannot give the red color to D because A and D share an edge with them, edge with them, right? So that's how I cannot give the same red color to C and D. Now, but I can give the red color to E. Why? Because there is no direct edge between A, E, right? Also, I cannot give red color to F. It's just that E and F are connected, right? It's connected by an edge, so I cannot give it a red color to this. But I can give it to G because you see this, both A is also not directly connected and E is also not directly connected to G, right? So I can give this color to this. Okay, so if this is the case, then what? Now, which all vertices I can give the red color? Can I give red color to H? Actually, I cannot. It's just because E and H are connected, so I cannot give the H the red color. But I can give it to J. It's just that E and J are not connected, and even D is not connected to G or A is not connected to J, so I am free to give this here, right? Likewise, I can give red color. I cannot give red color to H. It's just that J is connected to this. Also, I cannot give red color to B. It's just that B is connected to J, right? But I can give this red color to Q, right? So if I give same red color to Q, then I cannot give it to H and B, right? That's very obvious. But I can give it to any other vertices. Let's say I can either give it to P or K. So I have given it to K. So if I give it K to this, then I cannot give it to this P or H or B for that matter. Like that was already ruled out in the beginning. So this is one way of giving a color to all these vertices. But since now you can see there are so many vertices, several vertices which has not been assigned any color. So what we'll do is we'll start giving them color. Okay. So now what I can, let's say now the next color which I choose is green. Okay. So now if I give this green color to C, then I cannot give it the same green color to which all vertices. I cannot give it to uh, basically A and E, but they already have a different color. So you are not touching them, right? But you can give the same green color to D because they are not directly connected, right? If D gets the color, can F get the same color? Can anybody say this?
Yes, both can be the same because they are not adjacent.
Right. No, no, no. F. I'm talking
Ah.
about F.
F cannot
If
cannot
and
get red or green.
Right. So F cannot get the green. It's just that D and F are connected, right? So that's how we cannot give a green color to this, but I can give it to H. It's just that H is not connected to either C or D, right? Directly, it's not directly connected, so I can give it to this. But the moment I give green to H, I cannot give it to B. It's because it is directly connected, right? But then I'm free to give it to P because P is nowhere connected to H, D or C, right? So like I have covered these vertices. Now again, I'm left with two vertices. So can I give the same color to these two vertices, F and B?
Yes.
Yes, I can give the same color to F and B. Let's say I'm giving it yellow. So now what? I have given it yellow, and why I was able to give the same color to this because they were not directly connected, right? So you can see this, all these vertices could be covered in how many colors? Three colors, right? So this is one optimization problem where we find the minimum number of colors required to actually cover all the vertices, to color all the vertices, right? But then what is the application of it? So having known what is vertex coloring, you will be able to appreciate a real life problem. So this is a real life problem to you. And this is something based on coloring concept. So let's try to solve this. So you see this, a particular question is, a company manufactures 10 chemicals. Certain pairs of these chemicals are incompatible and would cause explosion if brought into contact with each other. Okay. So below graph, which is I'm not showing yet, I'll be showing it in the next slide. Below graph shows that incompatibility of the chemical. Each vertex represents the chemical, and each edge between the pair of a chemical represent those two chemicals are incompatible. Okay, so as a precautionary measure, the company wishes to partition it in a warehouse into compartments and store the incompatible chemicals in a different compartments. Okay, so this is the graph which is given. So now I'll just explain it again. Basically, this vertices indicates the chemicals, and this connection between these two chemicals indicates that they are incompatible. That means they cannot be stored in the same warehouse. Okay, so if they are placed in the same warehouse, what does happens? It creates an explosion. So what we have to do is, if these two vertices say shares an edge, so what you have to do is you have to place it in a different compartment altogether, right? So this would have given you kind of a hint that, okay, if I can color this, this is kind of a coloring problem, right? You can just get a hint of this, right? So these vertices basically indicates the color, and this line or the edge between them indicates the incompatibility of these two chemicals. That means I can store F and A on the same color, basically on the same compartment, because there is no direct edge connection, right? And also J and A cannot be placed on the same compartment. It's just that they are explosive when they are put in the same compartment. So likewise, if this is the thing, then the question to you is how many compartments are required? Such, right? Sorry. So how many compartments altogether do we need? So you can just start giving your answers over here. So now you have so you can just think of it's basically, you know, a graph is given to you and you have to do the coloring thing. Maybe you can read, if you can understand this particular question, then you will be able to appreciate it better. Well, for time being, I want you to answer this particular question. So maybe I'll give you 3 minutes to solve this particular question. Okay, so I guess you don't need more time. Do any of you need more time? And please do not post answers in the chat window because that will disturb others. If you want to answer, just go to joinpd.com and use this code which is given in the top right corner. So do any of you need more time to solve this particular question? Okay, so assuming that you don't need more time, let's see what are the popular answers for this. So the answers is between 3 and 6, and most of you are giving answer as 4, and even significant number of you are giving answer as 3. Well, let's see this, because I cannot ask you to give I cannot discuss with you because it's kind of hard to, tell with the colors here. So I myself will discuss here. So you see this, as we started in the very beginning, we'll assign some color. So you see this, when I give F color, sorry, to this vertices F, if I give a red color, okay. So now what happens? I cannot give the red color to J, G, and B, right? Because they are directly connected. But then I can give it to A, or I can give it to D or whatsoever, but I have given it to A. So if I give it red color to A, I cannot give it to J again. I cannot give it to D, E, C because they are directly connected. And again, the red color cannot be given to B because B is connected to F and F has a red color. So now we understand this, but I can give it to I, and I is not connected to either A or F, right? They are not directly connected, but I can give it red color to I. So you could have actually given it to H also, but that's perfectly fine. You can choose any of these. So now if I give it to I, then I cannot give red color to H. Now, can you think of any other vertices here which can be given a red color? Can anybody tell me that? Is there any vertices where I can give a red color? Okay. So assuming that there is no other vertices where I can give the red color. Okay. So now
Sir,
what? Yeah. Yeah.
can't we give red color to okay. Sorry, got it.
Yeah. Got it, right? Okay. Just a minute. Okay. So now you can see this. I have given red color. So there is no other vertices, any other vertices where I can give red color. So all of you convinced with this? Okay. So now we choose the next color. Let's say we are taking green, right? So whichever the left place was, like if I give it green to Jake, then I cannot give it to or any of these. Like, of course, this was connected with all the other three vertices, J was connected to is already assigned some color. So that's okay. Then I can give this green color to any other vertices. I could give it to B also. But again, since I have already given to C, so let's say C, we are giving C the green color. So if I give it C green color, then I cannot give it to E, I cannot give it to D, I cannot give it to B, right? And also I cannot give it to I because I is already red, so that's perfectly fine. So you can see this, I cannot give it green color to B, D, E, right? But then I can give green color to either H or C. So let's say I give it to G, right? So there are other vertices too, which should be given some color. So now what? Which color is to be given? So let's say I give it a blue color. So if I give a blue color to H, I cannot give it to any of the other thing. I cannot give it to E essentially. So E has been given a different color because that is something left over. Likewise, I can give it to D. If I give D to this, that was perfectly okay because these were the only four vertices which were left. So H, if it gets the blue color, then I can give it D the same blue color, and I can give the same blue color to B as well because DB is not connected and DH is also not connected, right? So in that case, I'll be just left with E, and E can be given any color. Let's say I give it yellow. So altogether, how many colors are we using? Four colors. And now we can see that only four compartments are needed to store all these chemicals, right? So now you can see this. This is one of the application type questions of this coloring concepts. So you see this, there were so many vertices, right? Or so many chemicals. All these chemicals could be placed under four compartments and they would not create any explosions, right? So all of you clear on this? Or do any of you have doubt?
Is there a formula to kind of know how many colors can be used? I mean, suppose the graph is a lot more interconnected.
Okay.
Is
So
there a way to find out?
okay. So one hint I can tell you is there is no formula as such, but one
Mm.
hint I can give you is
Mm.
for a planar graph, if the
Yeah.
graph is planar, and
Mm.
there is actually a theorem. So if the graph is planar, so maximum all you need is like if the graph is planar, you can color all the vertices in maximum 4 colors, not beyond that.
Okay, okay,
Yeah.
okay, okay,
So this is one thing I can give you an hint.
okay,
So I hope you can understand this.
okay,
So
okay.
yeah,
Thank you so much.
yeah, welcome. So
Uh,
now let's.
Vicky,
Yeah.
yeah, actually, I also wanted to add on this because I am not sure in which lecture I saw it, but
Yeah.
like mostly when coloring or something. So I usually do start it from a vertex which has maximum number of this
Uh,
edges.
or yeah, or the degree, right?
Yeah, or the degree. Yeah, correct.
Yes, yes, that's right. Even actually, in fact, even I do it the same way. So this is something all of you can take an input from Alka. As Alka says, like you can start coloring. We can start coloring those vertices which has got the highest degrees, right? So you can see this. You can actually start coloring from A because you can actually rule out so many vertices that they might get the different colors, right? So if you were choosing A, so you could not give it to J, C, D, E, right? So there were like 4 vertices you will be ruling out, right? So that is one, a strategic way of solving these kind of questions. But again, you do it the way, however way you want. You can still get the answer. You can come at the answer, but that is one input that you can take from Alka. That's actually right. Thanks, Alka. Okay, so let's go to the next topic then.
I have a question. What do you
Yes,
mean
Anand.
by graph is planar?
Okay, so graph is planar means basically they do not share or basically the edges do not intersect each other. Over here, of course, these graphs are intersecting. So this is basically it's not a planar graph. But if I have to give you an example, so I can show you like this. Let's say if I have 4 vertices, maybe A, B, C, D, or let's give it 5. Okay. So what do I mean by planar graph is basically, let's say this is the original graph which was given to me. Okay. So planarity, if this is an edge connected like this, so I cannot have any edge crossing this particular edge and going and connecting other edge. So I cannot have this coming in like this. Okay. If I do this, I am violating the definition of planarity. So in planarity, what does it says is you cannot have an edge crossing another edge. You get it? So, but this can be shown like this. You can do this, but you cannot actually connect it like this. Now you can actually connect this with this. Now, how much more you can do? You can actually connect this, right? Can you connect any other graphs? Let's say, uh, can you connect AC in any ways
Uh,
without crossing any edge?
no, no.
No, you cannot have it. So if you go, suppose if you want to connect it like this, so what are you doing again? Essentially, you're crossing this edge, right? So well,
Yeah,
that is not allowed. That violates the planarity definition. Okay. I hope this is understandable.
yeah. Thank you.
Thank you. Okay, so now that was about planarity. So now let's go with the more concepts on this. So, but I leave it to you that you will study the other concepts such as independent set and the vertex cover, then matching problems. Like these are something already given to you, or at least like you have some materials from where you can actually study all this. These are actually really important concepts, and you will be tested on that. Okay, so that is one thing that I would say. This BFS tree I really wanted to discuss with the programming student, like those who were about to give the exam, but since they're not here, you can learn from here maybe. So you see this, what is this BFS tree and DFS tree? So do you know how to draw the BFS tree and the DFS tree from a given graph?
Yeah.
Let's say if I give you a graph and then I ask you to find out what is the BFS tree of this and what is the DFS tree. So are you comfortable with that? Or do you face any of you, do you face difficulty in that?
Actually, could you just give us a small explanation for both so we do not get confused?
Okay, sure. So fine, we can just take up one example maybe. Okay, let me take up this itself. Okay, let's say this is the graph, and this is like similar graph as what is shown here. You can see it's basically the same thing. I have taken it here. So now let's say if I have to draw the BFS tree for this. Okay, so in BFS tree, what do you do? So you see this is a graph, okay? And what is a tree? In tree, you basically don't have a cycle. So this is the graph given to you, and now I'm asking you find the BFS tree. So here I will find out the BFS tree, and here I will find out the DFS tree. So tree is basically what you do when you find BFS tree and DFS tree. So in BFS tree, you basically you don't have any cycles because it says no, it's a tree, and if it is BFS or DFS, all the vertices will be connected essentially. That is the thing that you have to take from here. Okay, so let's say we start our BFS tree from, let's say, vertices E. Okay, so now what do we do? As it is told, now BFS trees, it goes level by level, right? So from B, where all I can go? I can go to BC, right? I can go to B, I can go to C, right? You see this? You notice something from E, I can go to B and C. It's going on the same level. It's since if you would have seen the lecture or something, what you do is you put them in the queue, right? First in, first out condition goes for the BFS tree. So how does this happens when you visit, when you actually go to E, you can actually explore B or C, right? So that comes in the same level. Now let's say we are going in an alphabetical order. Okay, let's say we are going alphabetically or alphabetical order. So from B, I will explore the other vertices. From B, which all vertices I can go? I can go to either A or F, right? I can go to A
Yes.
or F, but again, I cannot leave C. I'll have to come back at C, right? And then C at C, from C, where all I can go? From C, I can go to where? I can go to G, I can go to D. So now to explain you better, how is this happening? Look at this. I'm exploring E. When I explore E, I visit which all vertices? B and C, right? So now what I exit from this? Now once I exit out this one, I will be visiting B now. Now let's say I'm done with E part. Now what I'll do, let's say I'm visiting B, but I'm doing it alphabetically, okay? Or let's say not alphabetically, I could actually write C and B, right? But let's say I'm going in this alphabetical order. That's why I have written B, C, right? So now what I'm exploring B. If I explore B, which all vertices will I go?
A and
I'll go
F
to A
and F.
and F. So now I'm done with B then, right? Then now what I'll do? I'll be checking. So what did I do? When I explore B, I'll be visiting A and F, and that's how it is written here. Now what? I could be doing more with this part, but let's keep that aside. Now what? I'm exploring C. When I explore C, which all vertices will I be going with?
G, D and G.
D and G, right? So D and G enters here. Now what? I'm done with C as well. So now you see this, I'm done with this. Now what? I have to go this way, right? It's like first in, first out in BFS, right? So when I go with, now I'll go to A. Now if I go to A, can I explore anything more? You can say F and B, but this is already explored, right? From
Yes.
A, I can go to F and B, but sorry, not explored, but F and B is already visited, isn't it?
Yes, yes.
Since it is already visited, I will not be going that. So this will not increment. So A is done. Now again with F. From F, where all I can go? So where is F? I can go to A or B, right? But again, A and B is already visited, right? So this is also done. This also comes out from this, let's say from this list. What about next entry? That is D. From D, where all I can go? I can go to G, C, or I can go to G, right? But this is again visited, right? So
Vicky,
this is
sorry,
also done out.
how did you remove C? Sorry, I missed that part.
Okay. So how
After
did
E,
I?
you visited B and then you went to A
Haha,
and
so
F.
okay, so from C, this was RC, right? So from C, I can actually go to GD.
Now, how did you, because from B, you cancelled out B and because after B, you traversed to A or F, right?
Ah, right.
So how did you then go to C? There is no connection.
Because you see, this was already, C was already in my list. So you see this in the beginning, what did you do? I'll just write down
E,
this. So first we are starting with E. So when I explore E, I go to which all vertices?
B and C.
B and C. So I'm done with E basically.
Yeah.
Now what you will be doing, you will be exploring B. So when you
Yeah.
explore B, which all vertices you will be
A and
visiting?
F.
So A and F enters the list, and I'm done
Yeah.
exploring B. Now I'll be starting with C,
All right. Okay. So
right?
that means, okay.
So you see this comes in the same level. You see this when I'm exploring E, I will be visiting which all vertices? B, C. So this is on the same level. Let's say if this was level 0, this is level 1,
1.
right? And over here, now this is one level we are done with. Now from B, now this was B, right? And we were exploring AF. So this is basically we are entering level number 2. So you will see this basically this is all at level number 2, isn't it? When I explore B, I go to what? I go to AF, right? So AF comes in the level 2. Now similarly, this C was in level 1, right? So I'm done with C. So if I explore C, which all vertices will I go with? D and
G.
G,
Yeah.
right? So I'm done with this as well. So now you see this, I'll be left with all these things, and these are at level 2, and we don't have any other vertices which is at level 3. So you can actually, explore all this and just rule out this. So now this is basically the BFS tree. You get it?
Yeah. Thank you.
Can we start with any other alphabet rather than E?
You can start with any other thing, but it will be told in the question from where to start and whatnot. Okay, that will be told. Is that okay?
Yes.
Okay. So now you understood how to build this BFS tree. So one thing that you can notice from here is, now this is your BFS tree. Okay. And what all things that you can take from here is, look at your original graph. The questions how it can be asked to you is, if this is your particular BFS tree, do you could you have an edge? Let's say the question will be, can BC have an edge in the original graph? The answer should be yes. It's just that you can see here, it's directly edge is given here. So you can say that yes, BC can have an edge. You understand this? Maybe I
Sir, could you repeat the question? BC edges?
So you see this, if this is your BFS tree, just a minute. Okay. So now the questions that can be asked in the exam, or like how it is like standard way of asking question. So what usually it is done is, they will give you the BFS tree and they will ask you the question, can this BFS tree, can there be an edge between B, C in the original graph? The question will be like this. Okay. So can they have this edge between them? The answer will be yes. Why? Because you see this, there is one rule, or you should not say even rule, or maybe it's just a practice that you can gain from here. You can basically have an edge on the same level. So you see this BC has an edge, right? But you don't have the edge in your BFS tree, isn't it? Do you notice that?
Yes, yes.
Right? You can also have an edge between C and F, though it is not given here. But you can still have, let's say if there was an edge between C and F, and if you draw this BFS tree for this particular graph, now it'll be the same graph.
Correct, correct,
Okay.
correct.
So
Will it not be, you have an edge from F to C, so you can traverse to F from C also, right?
okay,
So
so
after
let's
E,
check this
from
out.
E
Let's
to
check
C,
this
will you
out.
not have two lines coming in? Sorry.
Let's check this out. Okay. So now you see this, as we were doing this part, let's understand this. So you see this, we start from E. When you are at E, you explore which all things? B, C, right? Now E, and then you go with B and C, right? Now what? I am done exploring E, right? Now I'll be exploring B. Now when I explore B, which all vertices I'll be visiting? AF. I'm going in alphabetical order. AF. So B is explored now. Now you will be exploring C. When you explore C, which all vertices you will be visiting? Will you visit this vertices F again? No. You will be visiting GD. Sorry, or DG. So you understand this,
Yes.
right? it's essentially the same thing. Even if you have an edge, so you could have an edge between, you can have an edge at the same level, or you can have an maximum, or you can have an edge at one level above or below, right? But not beyond that. This is also a rule. So what you can have is, you can take from here is, you can have an edge at the same level. So edge at same level is allowed, right? So basically, if I have to tell you, if I have to tell you, if this is your BFS tree, can your original graph have an edge between C and F? Can they have an original graph in C to F? They can have, right? They can have, right?
This
Like a
BFS tree that you have drawn, it's
Yeah.
like E and after B you have written A and F. Instead, you could have written E, B, A, and under C you could have written F also, right? That also is
Come again.
correct.
Come again. Come again.
Instead of F and B having an edge in the BFS tree, the C can have 3 elements under that one, right? So
No, 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 but you have to explore it in an alphabetical order. This has also been told,
oh,
right? If that was not the condition, then you could have told it. Yes, that could have been the right answer.
Vicky, is it possible to have an edge between nodes at two different levels?
Two different levels, no. At max, at one level you can have.
Okay, so
So
C and F is not possible.
no, no, no. They are at one level above and below, right? So it's just one level above is, it's fine, but you cannot
Oh,
have at level I plus two. You
okay,
you are
so
allowed to have an
okay,
I plus one or I.
okay, so E and F is not possible.
E and F is not possible.
Yeah,
Yes.
because in the original graph there will be an intersection, right?
Right, right.
Okay, okay, great. Got it, got it,
You understood?
got it, got it, got it.
Okay. So edge at the same level is allowed, and also
One
edge,
level above or
uh,
below.
edge at one level above or below is allowed. Okay. So this is something we can take from here, right? So you understood, you got convinced with this. Now should we go to the next DFS tree?
Yes, yes.
Okay. So now in
Sir,
DFS,
sir, one question, sir. Under the rule number 2, uh, you said level 0 and you said level 2. So
ah,
I don't think,
your voice is breaking. Your voice is breaking.
sir, under the now it is better, sir.
Yeah, yeah, better, better.
So my question is, based on rule number 2, edge at level above or below is allowed. So between E and F, it's at level 0 and F is at level 2. E and F is,
Your voice is breaking. I mean, I cannot understand. I'm sorry.
no, sir.
It's just that hello part is audible, but when you speak a sentence, some part of it is breaking. I cannot understand that part. You were at level, you were talking something with E and F, right?
Yeah, E
Then
and
you
F,
can start from.
E and F by rule 2 is allowed, right?
No, no, no. You see this is level one or below. It's basically if you are at this level. So what is the one level above? One level above is this. Let's say you are standing here. So one level above is this. So you can have edge between this and this. So you can have edge between this, this, that is allowed. Okay. So that is one level. Or you can have this. You can have an edge between them. So well, you already have here. So that's fine. You understand now? But when
Okay,
you
sir.
go to this thing, it's like two level. It's like level number one and level number two. So it's two level, right? Clear?
Okay, got it, got
Okay.
it.
Okay. So now let's build the DFS tree for this and understand this. So now let's again start with E and same alphabetical order. So when I start with E, so over here
Sir,
in
sorry to
DFS
interrupt.
tree, yeah, yeah.
Hello. Am I audible, sir?
Yes, yes, yes.
Sir, I just wanted to clarify that you just told that we can have an edge between a level below and up and at the same level. So I just wanted to know that this is a possibility we are talking about. I mean, that doesn't necessarily have to be the case, right? I
Huh.
mean, we can have an edge, but
Yes.
that
Or we
does not
cannot
have
have
to
an
be
edge.
necessary.
Yes, yes,
Okay.
yes. You're right.
Okay.
So you see, if a BFS tree is given, a question will be asked, can you have an edge between these two vertices in your original graph? So you can have if these two conditions are being fulfilled. Okay. So that is the thing, but that's a may condition.
Okay.
Okay. Yes. So now let's build the DFS tree. So now in DFS tree, what does the name says? DFS is nothing but depth first search. It's just that what do you do when you search, let's say something, when you search in the Google, then you start searching. Now let's say you search something, and let's say you search maybe for some link on the Google, and then you find you get the another link. Then you find you get the another link, and then what we do usually tendency is like we search link after link after link after link, right? So that's how we do the depth first search, right? So that is how it is done. So likewise you can think of over here from, so when you're doing this depth first search, we have to keep in mind, like we are doing this counter problem. Let's say I start with counter 0. Okay, so this is my, let's say I'm entering E. So from E, where all I can go? Let's say I'm going alphabetical order. So I should go to B or C?
B.
B. So I'll go to B, but what will be the counter? Counter is nothing but the time counter. Let's say at 0 I started with E. Now I'm going to where? I'm going to B, and with what counter? Counter number 1. Now from B, it's a depth first search, right? So I have to go as depth as I can. Okay, so that is what it means. So from B, where all I can go? I can go to A or F, but which is alphabetically which I should choose? A. And with what counter I'll enter there? With
2.
counter 2. And from A I can go to F. Now assume there is nothing like this. Okay, so now from A I can go to F, right? Sorry, I can go to F, and what will be the counter? Counter will be 3. Now I'll tell you what is this counter. So now I'm at F. Now from F, where all I can go? I can go to B, but B is already visited, so I cannot go there. So now what? I'll start exiting. So now when I exit, let's say I write down the counter here. So I exit with counter 4. Okay. So now from here, now from F, I'm going back to A. With what counter? Counter, let's say counter number 4. Now from A, I'll go back. From A, do I have an option to go anywhere else? I can go to B, right? But B is already visited, so I exit A as well because it's already, I have done with A now, right? So now with what counter I'm leaving? Counter number 5. So I'm done with A as well. Now I'll come to A and I will check I can go to any other vertices or not, right? But from, sorry, not A but B. But from B, where all I can go?
C.
Now I can go to where? I can go to,
C.
I can go to C, but you see, notice one thing here. I can go to, from B, I can go to C, but I'm not exiting this B yet because I'm exploring B, right? So I'm not exited. Therefore, this exit counter did not come here. So now I'll enter C with counter number 6. So now
6.
you understand this. Now from B, I went to C. Now from C, where all I can go? Alphabetically, I can go to, I can go to D, right?
Yes.
With what counter?
7.
Counter number, let's say
7.
7. And from D, where all I can go? I can go to G. With what counter? Let's say 8. Now from G, where all I can go? I can go to C and D, but C and D is already visited. So I'll exit this G. So now I'll exit with what? 9, right? Now from, let's go back to D. From D, where all I can go? I can go to CG, but CG is already visited. So therefore I exit D as well. With what counter? Counter number 10. And now from D, sorry, now from C, where all I can go? I can go to 4 different places, that is DC, but DC is already visited, and BE, but B and E is also visited. Therefore, I exit C. So now with what counter? Counter 7. Now from 7, I go to B. Now from B, where all I can go? I can go to A, F, E, and C. But you see this, all this thing has already been visited. Therefore, I exit this counter now with what? Entry 8, right?
I think at C it has to be 11. The
Oh, yeah, I'm
exit
sorry.
counter.
Yes, 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 yes. It should be 11, and this will be uh 12. Okay. And what about 13?
When we
Sorry,
come back
at
to E.
E. So at E now you are free to exit this, and with what counter? Counter number 13. So how many edges are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9. Or like forget about the thing. How many things are there? Like 1, 2, 3, 4, 5, 6, 7. So all that you have to understand is when you're doing this counter thing, right? So whatever these vertices are, like how many vertices do we have? We have 7 vertices, right? So 7 times 2 is how much? 14, right? So you must have counter whatever the times 2 you have, like let's say there are some 7 vertices, so it's, let's say if there are n vertices, then how many counters you should have? If there are n vertices, you must have how many counters? N
N
times
minus
2
one.
minus 1. So these
N
many counters
elements
you
or
should
N
have.
vertices?
Vertices. Okay, if n
We have
represents number of vertices, if n
we
is
have
number
9
of,
vertices.
no, not 9 vertices. How many? No, no, no. For the original graph I'm talking about. So even here also you don't have 9 vertices. How many vertices do you have? 1, 2, 3, 4, 5, 6, 7, 7 vertices, where n is number of vertices. Okay, and n times 2 minus 1 is the total number of counters. Right? So how many counters do we have altogether? So it's like 7. So 7 times 2 is nothing but 14. 14 minus 1 is 13. So we have 13 counters. So now understand this. Now, like we told here, the edges at the same level is allowed, and here at edges at the one level or below is allowed in BFS tree. In DFS tree, what you have to notice is you can have edges at any level, but the edges between two different branches is not allowed. I hope you understood. You cannot have edge between C and F. So branch edges is not allowed. Cross branches, maybe that is the right word to say. Cross branch edges is not allowed. So you can understand this now,
So,
all of
but
you?
so this cross edges not being allowed in different branches. That is case with undirected graph, right?
Uh, you can take it with, okay, if you take it directed graph, so that is different case, but let's discuss this concept over here in DFS tree, that this is not allowed for this particular thing. It's basically, this is you cannot bring in, directed graph concept here, so you just keep that aside. Okay, it is basically, you can talk about for undirected graph here. Okay,
Okay, got it.
yeah. So cross branch edges is not allowed, but you can have edges between E and F at any level you can have, but you cannot have a new branch coming like this in your original graph, or this. Okay, or this. You cannot have cross branch edges. That is something not allowed in DFS tree, but you can. Now, what do you mean by this branches? So you see this is basically one branch. I have to use some different color. So you would notice that this is one branch, right? And this is another branch, right? There are two branches, right? So I hope you understood this. All of you understood this? I mean, at least, okay. So now, having known these two things, I would discuss here itself, like what are something called, some terminologies, like, there are some terminologies like, like we say, uh, cross, something like, with the branches, we will have concept like, what do you mean by forward edge? What do you mean by backward edge? And what do you mean by cross edge, and what do you mean by tree edge, like this kind of concept. So let's just take up a questions on this. So this is one question which I have taken from practice assignment, what we have in mathematics. So now, how do you basically understand what is forward edge and what is backward edge and what is cross edge and things like this? Okay, now look at this. Consider the following directed graph. So this time we have directed graph, and what do we have to do? DFS Suppose DFS of this graph is performed from the node A. So like I told you, you will be mentioned from where you have to perform. So here it says that you will start the DFS tree from node A such that when we visit a vertex, we explore the unvisited neighbors in an alphabetical order. So even this is mentioned that you have to go in an alphabetical order. So this is also mentioned. So which of the following are correct? CF is forward edge, FD is backward edge, AC is forward edge, BD is backward edge. Now, how do you solve this particular question? Of course, do not get confused when this is written like this, A to B, do not say this is forward edge. Though it appears that it is directly goes there, so it is forward edge, and do not say this as an backward edge. I mean, just by looking at the graph, you cannot say anything like that. So how do you do then? How do you solve this kind of problem is, you first make the BFS tree. Okay, so I hope you can see the screen properly. So how do you solve this? You basically make the BFS tree. So let's start making the BFS tree for this. Okay, so you start with A as it is being told, and you go with what? You go in an alphabetical order, it says, right? And then I will discuss this concept. What do you mean by, these things? You can make a note of this. This is actually important. So this was actually more important for, programming students. If they were here, it would have been very much beneficial. But even if you don't know these concepts, just learn it because these are very important. So there are some things like tree edge. Then you have something called, forward edge. Then something called backward edge. Okay. Then you have something called cross edge. So maybe you can just make a note of these four for time being. And this is the only thing which is required from our point of view. So now let's say I'm performing what? DFS tree, and we started with the counter thing. So let's say I start with the counter 0, right? And then where will I go? To A or C? Where should I go?
Go B.
Sorry, B, right? So I'll be going to B with what counter? 1, right? From B, where can I go?
C.
C or D. C.
C or D, but it has to go in alphabetical order. So I'll be going
Alphabetical
to
order.
C, right? With what counter? Counter number 2. From C, where all I can go? I can go to F, but with what counter? Counter number 3. From F, where all I can go?
D.
D. With what counter?
4.
Counter number 4. From D, can I go anywhere? No,
Now
so
you
I
have to go
exit this
back.
counter. So with what counter? Counter number 5. From F, now from F, where all I can go? I could have only gone to D, so I exit this as well. So with what counters? Counter number 6. Now I go to C. From C, I could have only gone to F, so again I exit this. And with what counter? Counter number 7. From C, sorry, now I'll go to B. From B, I could have gone to D, but I can see that D is already visited. Okay. So I can see that D is already visited. So now I will not be going to D, and then I exit B as well. So with what counter? Counter number 8, right? And now what about this? Now I'll go back to A and exit with how many which counter? Counter number 9. Okay. So now you see this again, as somebody was asking, like, can we hold this formula for this as well? So let's see. How many vertices do we have? 5.
5.
So it's like, I told you, right? So 5 times 2 minus 1. So how many how many, what is this? This gives you number of counters, right? So how many counters do we have? 9. So now you
0 should not be considered.
you can, if you consider that, then you can actually say that it has to be 2n, right? If you consider that.
So which is theoretically, which one is correct? Is it
Theoretically, you can ask me, if you are to ask me, if you it depends like what way you are thinking. If you just say if the number of vertices are 5, then the counter is 9. So if you say your counter starts with 0, then you can actually say that it is 2n.
2n? Okay.
But
Now
again, it
I
creates
have a
confusion.
doubt here, like, when you came to C, you we are going backwards. So this is now alphabetically speaking, you should have gone to B. But from C, you have an option to go to A and B.
But this is directed graph. You have to obey that as well,
Okay.
right?
Directed. So
Okay.
you'll have to follow the alphabetical order only.
Right. So yes, that is right. So now look at this. How many edges do we have? 1, 2, 3, 4, 5, 6. Right. So we have 6 edges. But in your BFS tree, how many edges do we have? 1, 2, 3, 4. That means there are 2 more edges which is not covered. So which are those 2 more edges? Let's look into that. From A, I could see there were 2 edges going, right? But in this BFS tree, sorry, DFS tree, how many edges do I have? Just 1. So from A, I have gone to B, and that is something shown here. But from A, I can also go to C. So that is something I'll show like this. Note that this is only your DFS tree, okay? Whatever I'm drawing in the other color is not a part of your DFS tree. It's just that I'm highlighting that there was an arrow, or there was an edge, or there was a way to go to C from A, right? Now I'm left with one more, and I think that is from B. I can go to 2 places, that is C and D. So from B I was going to C, but I was not able to go to D. So that is something was not there in my DFS tree. So something I'll show it like this. Okay. So now you see something which is shown here in this red color. This arrow which is shown in the red color, this is called as tree edges. What is that called as? Called as tree edges, because that is the part of original DFS tree. Now, and what you see here in this green color which is marked is called as forward edge. It is going forward. You can see that it is going forward. Had it been some edge like this, then you would have told that this is a backward edge. But over here, do you have any backward edge? The answer is no, we don't have any backward edge in this particular DFS tree, but we have how many forward edges? We have two forward edges. And how many tree edges do we have? 1, 2, 3, 4. So how many tree edges do we have? 4. See, basically, when do you get this concept of cross edge? Cross edge is something when you have a, let's say, two different branches of this. Let's say if I had another branch, let's say here there was G and then I had I. And if there is an edge between these two things, let's say if there was an edge between these things, this is called as cross edge. Okay. So now you have to understand there is no cross edge to here. So what is cross edge? Cross edge is edge between two different branches is called as cross edge. Okay, backward edge is nothing but like something which is shown here, right? So this is called as backward edge. Forward edge is something shown in the green here, that is called as forward edge, and tree edge is very obvious. Now from this, which is the right option?
Yellow,
Is
can you repeat,
CF?
sir?
Is CF a forward edge? CF
Yellow,
is
can you
CF a
repeat, sir?
forward edge?
No, CF.
CF is
AC
not
is
a
a
forward
forward
edge.
edge. AC is a
CF,
forward edge.
huh. So, but which is forward edge then? AC is forward edge. Okay, fine. Uh, FD is backward edge. Now, where is FD? FD is not a backward edge. It is a tree edge, right? So this is also wrong. BD is backward edge. Now, where is B? BD is not a backward edge. It's basically a forward edge. So this is also incorrect. So only AC is right. So now I hope you understood what is tree edge, forward edge, backward edge, and cross edge. So you can just make a note of this.
Sir, tree edge, yellow, can you repeat, sir?
Previous what?
Tree edge.
Tree edge. Tree edge is this original edge in this DFS tree. Like whatever tree, like let's say if I make a BFS tree or a DFS tree, whatever this original edge is, which is marked in the red, right? That is called as tree edge. Clear?
And cross edge.
Cross edge is like, let's say if you had, no, I'll just show you an example. Let's say 1, 2, maybe I'll just erase this part. Let's say I had another edges like G. Let's say I had H. And then I had, let's say, I. Okay. So if I had all these, and let's say if I have an edge something like this, okay. So this edge, this particular edge is called as cross edge. Okay. This particular edge. So you see this, what kind of edge is this? It is between two different branches. So this is between two different branches. Right? I hope you understood. Clear?
Vicky, you mentioned in the previous slide that edges between different branches are not allowed, right? So that's for
Right.
yes,
No. What
yeah.
I'm trailing is, if I have to draw the DFS tree, now this thing, something I showed you in green just to mark that what are these edges called. The BFS tree is only which is marked in the DFS tree is something marked only in this particular thing.
Okay, understood. Okay, yeah.
Okay, yeah. So that was simply to tell you that there is an edge which is not a part of DFS tree.
Yeah.
Okay. Yeah.
Sir, one other question. In this CF is why you are saying is not correct, sir. CF is going forward only, no?
CF.
Yeah.
So CF, yeah, that's what I wanted to make it clear here. See, once you make the DFS tree, whatever the original edges in the DFS tree are called as tree edges. They are not called as forward edges. I hope you get it.
Sir, don't understand, sir. Please repeat.
Okay. So you see this, you had been given a graph like this. Okay. From this graph, I made this what? DFS tree, right?
Yeah.
So once you make the DFS tree, you will have some edges, right? In your original DFS tree. Those edges are called as tree edges. They are not called as forward edges. Okay.
If the options are given as checkboxes, that means there has to be multiple answers, correct, right?
Need not be. We can just give it as one also.
Oh,
A.B.
okay.
Yeah. Okay. So you understood this now? The original edges in your DFS tree is called as tree edges. Okay. Forward edges, though the name says, looking at the graph, it says that, yeah, this is forward, so this is forward edges. Do not make that mistake. That is why I wanted to specifically distinguish between these edges, and that's why I wrote this. Okay, so that you don't make error, because see, even if I don't had an idea, and if I just simply go to exam and see this particular graph, and I see that, okay, CF is forward edge, so I can just tick this option, but it is actually not. CF is not a forward edge, because there is a difference between forward edge and a tree edge, right? I hope you get it now.
I'm sorry, sir. Sorry for my poor understanding. I'm not able to understand, sir.
Okay, so I would tell you that you can actually maybe you can start seeing it elsewhere, or you can see some books, because we have limited time and I cannot give you more examples
Okay,
here
sir.
to explain it better.
Okay, sir.
Because I can just tell you one thing is, if you can understand what is tree edge, then you can definitely understand what is forward edge. Any of
Probably,
these, yeah.
yeah.
Okay, you can just take a screenshot of this or like whatever, but try to see it elsewhere, like what is the thing, because even I have time constraint, so, and I cannot tell you at this point of time like the whole concept. So well, I think you can just see that part how it is done, but it's very obvious to understand if you just go through that. Okay, so now these two concepts I have already discussed in that particular one note. So now let me take you to one question, this particular question. Now, suppose we obtain the following BFS tree rooted at node A for an undirected graph with this particular vertices. Which of the following cannot be a possible edge in the original graph? So note this is BFS tree. You have been given 4 options. I'll just give you 1 minute to solve this particular question because we don't have much time. So quickly solve this question. And it's very obvious if you have seen my explanation, what I have given, you can actually answer this particular question. So try to solve this question. Which of the following cannot be an edge in the original graph? So this is basically a BFS tree which is given to you. This graph indicates the BFS tree. Now the question is, which of this edges, like which is given here in the option, cannot be the part in an original graph? That is something you'll have to answer. Okay, so I assume like, do you need some more time to solve this? I guess it's not. So let's see. Can somebody tell this? Can somebody give this explanation for this apart from?
I
Hello, sir.
think E.
E and I,
Yeah.
C,
because
E and
E and I, option C, they are not in the adjacent levels.
Okay. Okay. Maybe let us see first responses. What are the responses? So most of you giving answer as C. Yes. So yes, who want to speak can maybe
so
just,
C
yeah,
option.
yeah, please go ahead.
Yeah,
Option
C is
Alka, right?
it's Ulka actually.
Oh, okay. Sorry. I'm sorry.
No.
Ulka, right?
So
Yeah,
if
Ulka.
we
Yeah.
see for A, B, and C, so the level that these two vertices are in, so the difference between the level of these two vertices, they are less than
Okay.
one or less than one. But for C, E, and I, the difference in the levels is two.
Hmm.
So in BFS graphs, if we want to see that whose edges can be connected, it can be either one level above or one level below.
Hmm. Or at the same level.
Yeah.
Hmm. Right? So with that thing, you are saying this is the option. So basically, I'll discuss the solution here. Thanks, Ulka. I'm sorry, Ulka. So you see this? Look at this BK, this edge BK. So where is this B and K? So let's look at this B and K. So now, what is the level difference? It's 1. right? So they can have an edge, right? And in the question, you'll have to find out which is possibly not an edge in the original graph, right? So B and K, they can have an edge in the original graph as they have one level difference, right? What about Mn? So M and N is again one level difference. So they can still have an edge in the original graph, that is also allowed. EI. Now let's look at EI. So E is here. This is at level 2 and I is at level 4. So now the difference is 2 levels, which is not allowed. This cannot have an edge in the original graph. So this is one option correct. What about EH? So E and H, this is one level difference, so they can have an edge. So only option C is correct. So I hope you understood this, all of you, right? So this is all for today's session. This is the same explanation which is given here. So option C is correct. So now if you are to ask me, most of you have some kind of thing, questions like, so basically mathematics for data science, we don't have any prescribed book. All we just tell you is like go through the NCERT textbook of class 11th and 12th, only those selected topics which you can go through. And if you want to supplement like with more problem solving things, just solve those particular questions again and again. What is must for this particular thing is like, at least like whatever I have discussed here, you can actually practice those questions. Try to do similar kind of questions at least. And you are aware that in your exams, you will be asked with two type of questions, that is NAT and MSQs. MSQs can have one options correct. It's not like it's mandatory that, there should be two options correct. So do not go with that assumption. It can have one options correct as well. So you see this, you have to be really careful when you're solving this MSQ type questions, because let's say, if, even if you choose one incorrect option, you will get no marks for that particular question, right? Let's say if the question is for 5 marks, okay, and the two options are correct, right? So let's say two options which are correct, you have marked them, but you feel that even the third option is right, and by mistake or like by chance you have chosen the other option as well, so you get 0 marks. So it is that bad. So be very cautious about when you're solving MSQ questions and choose only those which you are very sure of, like these options can be correct, be like that. And NAT is like you have infinite ways of making mistakes, right? So even though, like it's from my experiences also, I can say that, when I solve question on the paper, and while let's say I got answer 5, and during the exam pressure I might give the answer as -5, or let's say something else answers, right? Or that's, there are infinite way of making error in NAT. So both are equally dangerous. So I would say is like you can just practice more questions of this type, right? And if it is MSQ, choose only those questions which you are very much thorough with. So this is all for
MCQ will
today's
not be
session.
there, sir.
Like I told you, like in MSQ, you can have one options correct, which is similar to MCQ, right? Like if you don't have, then you don't have. Yeah, it's just that. Yes.
Sir,
I
can
had
you share
one.
the recording of this class?
Oh, so basically this is not recorded. So you can just have the slides. I can share you the slides afterwards, maybe.
Sir, with this, the classes are over, or you have some more sessions on math?
Yeah, I have some more. Right.
You have some more. So, in earlier classes, up to what week you covered, sir?
So earlier classes, you see, up to week 1 to 4 was covered, and then calculus part was covered. In this particular session, I covered exponential and logarithmic and this normal graph problems.
Vicky, when will see, because exam is coming up on coming Sunday, not this
Yeah.
Sunday, next Sunday. So when will we have one more math session?
You don't have any more session, I guess.
Okay.
Like we already have 3 sessions, so we
Correct.
don't have any more.
Okay.
Right.
Okay.
Yeah.
Thank you, Vicky. Thank you so much. Thank you, everybody. Bye-bye.
Yeah. Thank you. Yeah.
What is,
So we can just
sorry,
exit now.
you
I had one question regarding the MSQs. So,
Yes.
so suppose like you said that no marks will be awarded if even if we are choosing one of the incorrect options. So,
Correct.
so if there are like 2 or 3 correct options and we have only chosen 1 or 2, so will that also be equivalent to 0?
Oh, sorry. Could you repeat again?
So I'm saying if we choose 1 or 2 out of the 3 options which are correct, so will we be
You will be given marks for that.
okay?
The partial marks will be given for that.
Okay, but in case of incorrect one, all will be deducted.
Correct. All will be deducted.
Hello, sir.
Yes.
So one more doubt. I mean, we have talked about this vertex coloring and all. No, are we allowed to carry this color pencil, such kind of things to the exam hall? I mean, which helps out in
I don't
such
know if
kind
it
of
is.
a.
I think you can carry until or unless it's an electronic device, or you can use the pencil one, or maybe if you have this vertices, you can just say, let's say you can use alphabets as your color. Let's say A indicates red, B indicates,
Okay, but
green or
actually,
something like that.
I tried that way. It was
Okay.
confusing little bit, so I just
Yeah.
wanted to clarify. Are we allowed to carry?
Yes, yes. I think that should not be a problem, I guess.
Okay.
I mean,
Thanks.
that's
Thank you
completely
so
fine.
much.
Yeah.
Thank you so much,
Sir,
sir.
is there any recorded version of it other than this, if possible, if you can share it?
I don't know if other than this recorded version means.
Any of the other math sessions, because I had to miss out few of the math sessions.
Okay, I don't know if the previous two sessions were recorded or not, but this is not recorded, that I'm sure of. I don't know, let me check it out. I think it is not recorded. It was the previous sessions were also not recorded, but the slides which were used by the instructors is shared with you. So you can just go through them once, maybe you will have an idea like what was asked. Okay?
Okay, okay. Okay,
Yeah.
sir. Thank you so
Sorry,
much.
Yeah.
You'll be sharing today's
no,
slides also,
you
right?
said
Yes,
the
yes, yeah, I'll share that. Yeah.
MSQ and then the other one was NAT. What is?
NAT, right.
I'm sorry. What is NAT? Is it
NAT is
descriptive answers?
numerical answer type. Numerical answer type.
Descriptive ones, like where you
Not
give step by
descriptive,
step.
not descriptive, but numerical.
Okay.
Yeah. You will have to enter some integer values maybe. Integer or like a whole number.
Sir, I had a doubt in NAT when we were
Uh,
about to add the 25 percentage. No, we were not able to type percentage. So is it
Oh,
fine?
that's fine. That's fine. If it
Verify?
is asked in percentage, you can just enter the numerical value. That's all.
That's fine not to enter.
Yeah. Yes. Yes. Yes.
Okay,
Yes.
sir. Okay. Thank you.
Yeah.
Excuse me, sir. I have
Mhm.
one question regarding the syllabus. In the
Mhm.
syllabus, they have mentioned L'Hopital rules and derivatives, but
Hmm.
these are not available in that Maths 1 video lectures. So will there be questions on them, like L'Hopital
Yes.
rule and
Yes.
integral?
Yes. Yes. I don't know. The calculus part is not at all given. Like calculus videos.
No, that limit part is there, but no questions are there in that mock test and as well as in the videos.
Okay, but
So
there
even for
might
in
be
that
questions on
video,
L'Hopitals. I
video playlist also, na, I didn't find any lectures for taking the derivatives and all.
okay.
Couldn't find calculus related stuff.
Yeah,
Okay, so
integration
you
and
see,
derivation.
okay, so you are writing programming paper or like the
No,
programming one?
not
Data
programming one.
science.
Data
Data
science.
Data
Yeah.
science.
science.
Data
Okay.
science.
So
Data
for
science.
mathematics, for data science, you must have calculus, and that you will have lot more questions being asked in calculus. So let me see if it is provided or not internally, and then if it is not provided, we'll definitely do that.
Okay.
Okay. Yeah.
Thank you, sir.
Yeah.
Thank you.
Thank you. So thank you all, and
Vicky,
good night.
I see that
Yeah.
there is a message that says recording is in progress. If this is recorded, can you please upload it somewhere?
Yes, yes, yes. If it is recorded, then definitely will. I don't know. Yeah, I think it is
It
being
is there at
recorded.
the top near the
Yeah, yeah,
time.
No,
yeah.
actually,
It
yeah.
shows that.
And actually, we had mailed a supporting team also, but we didn't get any response from them. So, if possible,
I
can you
no,
please check
I
it
I
out?
Sure,
saw
sure, sure.
the Python videos have been uploaded yesterday.
Okay.
Okay.
Okay, then surely I'm doing this. Even this is recorded, and I think if this is recorded, then the earlier will also be recorded. So we'll provide you.
Yes,
Don't
sir, that
worry.
would be really helpful.
So
Yeah.
we'll make sure that by tomorrow you will have that with you. So don't worry.
Okay.
Okay.
Thank
Yeah.
you. Thank you. Thank
Yeah.
you.
So thank you all. So good night.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank
Thank
you.
you.
Good night.
Sir.
Thank you.